Welcome to the session on programming with Lambda expressions in Java. My name is Venkat, Subramaniam. We're going to talk about some of the wonderful things we can do with Lambda expressions. Too loud? Static? Distorted. How about now? Still? A little better. How about now? Good? That's what we'll do. All right. So we're going to talk about Lambda expressions, and it's a bit funny because I'm the one who is being complaining constantly that Java sucks. So for me to be here to talk about how wonderful Java is, and it deserves every bit of the credit, is fantastic. So I'm going to talk about the next big thing in Java. But if you really think back in time, what happened in Java? Well, when Java was first introduced, we had some interesting features. Then came along Java 1.1, and then nothing really happened until Java 5, which had some very questionable features. And then, of course, Java 6 had no real feature at all, language-wise. Java 7 has one of the most wonderful features in my opinion. You could put underscore in numbers. As I'm getting older, that's a feature I really like. Well, of course, nothing really exciting happened until Java 8, and all of that really changed for the good. So let's talk about what's happening in Java 8. Well, one of the very first things is Lambda expressions. And that is one of the biggest things in Java, but what does it really mean to have Lambda expressions? Well, let's start with a little example. Take a look at a code we have written maybe 1,000,000 times over, and then we'll refactor the code to see how we can apply Lambda expressions from there. So let's get started with a little example. As you can see, I don't use any slides over here. If you're interested in downloading the code examples, or the list of topics I have here, they're available on my website. You can download them anytime you want to. Best time to ask a question or make a comment is when you have it, so please don't wait till the end. Anytime is a great time for questions, comments, just about anything. Just draw my attention. If I'm not looking at you, just draw my attention. I'll be more than happy to listen to you. So let's get started with a little example here. Let's say we have a list of integer values, and we'll call it as, well, let's call it as numbers for a minute, equals arrays.asList, and let's say the values here, just a bunch of values, some initial values. Let's take an example and work with it. And let's say I'm interested in iterating through these numbers and printing their values. How would I go about doing this? Well, we all know how to do this, right? So we could say for int I equal to 0, I less than numbers dot, is it length? Is it size? Are you sure it's size, not count, not length? Okay. And then we would say I plus plus, oh, is it less than or equal to? Less than. Will it ever be less than or equal to? When you have that off by one error, right? So, and then what do? We will say numbers dot get again and put a value to it. Well, if you run this code, of course it works, but what did we just do? If you're into design patterns, I have a name for this pattern. It's called self-inflicted wound pattern. And this is what we do to ourselves, right? Now, sometimes when you hear people say, that's a simple for loop, they got the word highly mistaken. The word simple has nothing to do with this. What this is a familiar loop. And familiar doesn't have anything to do with simple. Familiar simply means you know it fairly well. Kind of like my in-laws are familiar, but I wouldn't say the word simple with them anyway, right? So the point really is that it's a very familiar for loop, but I'm going to say this is one of the most complex for loops you would ever write. Well, wait a minute, complex? Why is it complex? Well, it's complex because look at the number of moving parts you have in this code. You got to initialize I properly first. You got to set up the boundary properly. You got to then make sure you get the right value. And how many times have you written this code and stopped and said, did I get it right? That's like walking in the mall with a guy with a knife in the back, right? So you keep looking over your shoulder to see if this is okay. And this is way too complex to be writing. Let's try this one more time. We have a bit of a simplicity already on our hands. We could say I in elements and numbers, and then we could simply output the element directly. Well, that's definitely a lot better than what we just did. But collectively, these two things are given a name called external iterators. So what's an external iterator? External iterator is like having a rude dog. You say move, it doesn't move. You got to push it every step of the way. So the point really is you control the loop in all by yourself every bit of the way. And so you're so focused on the effort to really maintain the looping. On the other hand, what we can use in Java 8 is, coming from the functional style of programming, is the so-called internal iterators. So what is an internal iterator? So internal iterators are really like throwing the frisbee and the dog goes to get it. So the idea is you don't really control the looping, you put the looping on autopilot, so you can say, for example, numbers dot for each, and then you can simply say, I want something to be executed for each of the elements in this collection. So this is called an internal iterator because rather than sitting outside and managing the loop, you focus only on what needs to be done for each element in the loop, and then you can let the underlying code take care of it. Now, how would we go about writing this, of course? Well, let's go ahead and try this. What I'm going to do here is to use a very familiar syntax. And so I'm going to say new consumer, and I'm going to say this is integer. Well, what is this consumer? Well, consumer is a new interface in Java 8, but the syntax is pretty familiar. We've used this before. So I'm going to say function dot, and then in this case, of course, I'm going to say whatever I'm going to say here is the consumer that I want to bring in. So in a sense, what I have here is the consumer interface brought in. So I'm going to simply say public void accept, and in this case, integer value, and I'm going to simply output the value right here in this particular example. So if I run the code, you can see it produces exactly the same result as the previous code did. However, there is a huge difference. And the difference is, rather than trying to write a for loop, what does a for loop give you? A for loop gives you exactly what you asked for, which is A. And in addition to that, sequentially executing the code, right? On the other hand here, we're not saying how the loop is executed. We simply indicate that the loop needs to be executed, which means this loop could be sequential, this loop could be concurrent. There are several different options available, but how so? Well, we know this is polymorphism. You tell it what to do, not how to do it, and because you don't tell how to do, it is easy to change what you don't tell it to do. And that is one of the biggest benefits. I know what you're thinking along the way. You're saying, this may be the best thing ever, but if I have to use this, if I have to write yet another anonymous inner class, heck no, right? I mean, is there anybody in this room who gets up in the morning and feels excited that, yeah, I'm going to go to work and write yet another anonymous inner class, right? No, you probably called the boss and said, I feel really sick and call it a day, right? So that's really a very, very noisy code. And what is it that we're really looking at? That's all high ceremony. In fact, it's pretty silly because if you really think about it, what do we really want to do? What we really want to do is execute line number 20 in an iteration. Now, what is line number 20? It is a line of code. It's an expression. Okay, we could say it's a function. But what did we then say? We said, oh, function, you don't really have any chance. We are an object-oriented language. So it is accepted treating these functions as a second-class citizen, or maybe like kindergartners, right? This function comes to you and says, excuse me, could I go to the neighborhood park? You say, no, sweetie, you cannot go alone. We'll send an adult with you, right? So the point is we have to wrap this function into objects all over, but why not simply send a function directly to functions that deserve to be receiving functions? So notice what I'm going to do here. I'm going to repeat this call, but what is this part right here? This part is ceremony. It's a pure noise. It doesn't add any value. So I delete the ceremony. That leaves the function parameter. Then I put a little arrow and then come back and remove the remainder of the ceremony. And you can see the code still works. So the only difference between these two is we got rid of the noise. We got rid of the ceremony. We got rid of all that ugliness we had to write. So you're just listening to the essence, which is a parameter list followed by simply the function or the body of the code. Well, functions typically have four things. It's got a body, it's got a name, it's got a return type, and a parameter list. Of these four things, you would agree that the body of the function is the most important. Well, right here is the body of the code. The body of the code that or the function you're dealing with is to the right of the arrow in here. And so there goes the body of the function. To the left of the body is the parameter list, and of course that makes an anonymous function. You don't have to really give a name for it, and the return type is interpreted based on the context. So we have a little function on our hand, and we are passing it around. However, there is one other improvement we can make in Java, thankfully. If you look at this code for a second, notice that we are dealing with numbers, and of course, no doubt, what is numbers? Numbers is integer. Now, what are we saying here? We are working with an integer. Well, think about this for a minute. If you're going to loop through a collection of integers and you take an element, do you have the wildest guess what type that would be? Like a dog? A monkey? No, of course we know it's an integer, right? So why in the world, so you know it's an integer. Does the Java compiler know it's integer? Absolutely it does. Then why are we saying the stupidest of the most daring known thing over and over and over? So one of the principles I follow in life is never say the obvious, except at one point, like when you meet the spouse, you say, I love you, that takes us the rest of the day. But anything else, don't waste your time saying the obvious, right? So the point really is that you don't have to waste your time and effort specifying the most obvious, and for the first time in a long time, finally, Java is intelligent. So you don't have to specify the type at all, as you can see, so that works just fine without it. But of course, there's one other simplification we can make from here. We can simply remove this noisy parentheses if it is a single value parameter, and we can get rid of that as well. So we started refactoring the code until this point. Now we are almost to the end of this, but there is one more little improvement we can make in this particular code. If you notice this specific code, just take a close look at this. What is it doing? Now clearly, you could have taken this value and you could have done something with it before you sent it to the print line function. You could have multiplied, you could have added, you could have done quite a number of things. But the point is, you didn't. And so what you just did is, you took the value and without touching it, you simply handed it off to the print line function. And about the second time you write this code, you would say that's pretty stupid, right? And so, but one thing we have known from history is, Java programmers never write stupid code. Instead, they invent RPGs to bomb stupid code. So they knew this was coming, so they decided to really give a better way to handle this. But I have a special name for this pattern. I call this the office space pattern. Remember Tom from Office Space? What do you do, Tom? I take the requirements from the business people and I give it to the programmers, right? So this is kind of like Tom doesn't do anything useful. So we can get rid of that very easily by saying, well, here's the value. I want you to simply route it to the print line function right here. And so notice in this case, we have done a very simple routing, and this is called a method reference in Java 8. So a method reference is very useful and powerful when you are doing a very simple pass-through, meaning you're not really altering the input, you're simply passing it through. But method references are extremely smart. Method reference could be routed as a parameter to another function, but it could also be like target to a function as well if you simply want to call it from within another an object, a function on the object as a target. You can do that as well very easily. So that gives us an idea about how we would go about implementing this in the code. So with that said, we talked about a little bit of a refactoring here on our hand. We started with a very clumsy but very familiar for loop, which is an external iterator. We then refactored it to using an internal iterator using the high ceremony anonymous inner class. Then we replaced it with a Lambda expression. So this gives us an idea that we could send a Lambda expression anywhere an anonymous inner class is needed. But actually it is so that you can send a Lambda expression wherever a single abstract method anonymous inner class is needed. In other words, if the interface is a single abstract method interface, you can pass either an anonymous inner class or a Lambda expression, or in special cases you can send the method references we talked about. So this shows us how we can remove that ceremony and focus on really things like the internal iterator, and that reduces the noise in code quite a bit. Any questions, comments before we move on? All right, okay. So thanks for sharing that. So let's continue further now. So the next thing we're going to talk about is we just looked at refactoring and how we were able to refactor this code to the internal iterators. But this is really a fundamental shift from an imperative style to a more of a functional style of programming. So what does a functional style of programming really bring to the table? Well, it brings two things to us. One is declarative style of programming, where you tell what you want, not how you want it. And in the imperative style, you often say how you want to do it as well. So to understand this, let's take a look at one another example where we would normally get into a bit of a mutability that we would have to work with. So what I'm going to do here is to take this example of the numbers one more time, but with these numbers, let's do something a little different. I want to double each of the numbers and I want to total it. So how would I normally do it? I would say total equal to 0. I want to output the total value. Then I would say for int I equal to 0, well, we can spare that. Element is numbers. And then what would you do? E equals, and then you would say plus equals rather, total plus equals, and then E times 2. And then that would do the total of the numbers for you. So what did you do? You created a total, which is initially set to 0. You loop through every element, take each element, double it, and then add it to the collection, and then eventually you printed it out. So that is a very familiar loop, isn't it? But the question is, have you done this before? Yeah, you look at the reluctance, right? You never want to admit that in public. Absolutely, I understand. But the more important question is, when you write code like this, how do you feel? Dirty, isn't it? If you go home in the evening and the children come running to you, say, don't touch me. That's how it feels. In fact, it's even worse. Those of us who work from home, if the kid runs into the room, you got 10 seconds to close the monitor. Otherwise, the kid looks at it and says, that's what you do for a living? Right? So, absolutely. It's very low level, and that's what you're writing code. Well, we can do a lot better than that, thankfully, now. So, how do we really write this in a more of a declarative style? So, notice what I'm going to do here. I'm going to say output, and in this case, I'm going to start with the numbers.stream. Hey, what in the world is a stream? A stream is a fancy, very fancy iterator. We're used to iterators in Java, but what does the iterator in Java give us? It gives us two things, next and has next. Well, this one is a very fancy iterator. It has a very nice set of methods available for us, so we can use some really nice, fun things with it. So I took the stream, and I'm going to perform an operation in this case, and the operation I want to perform is called a map. And the map operation says, given an element, double the element. So if you look at this map operation, this is a very common operation in functional programming. This performs what's called a transformation operation. Now, once you get a hang of this, you realize that this is extremely expressive. You're saying that if I get a stream of values coming in, for every single element in the collection or the stream, I want to perform a function, a transformation function, that transforms these values into this other value. So rather than putting your focus and effort on how to actually manage the looping, you shifted your focus on what to do per element rather than how to manage the collection of elements. The managing the collection of element has been kind of given off to this function called map, and it says, I'll take care of it, you don't have to worry about it, and so we can simply focus on this. So map applies, and apply is the right word here, map applies this function on every single element in the collection and performs a transformation. So if you have 20 elements coming in, you're going to have 20 elements going out of the map, but every single element is a transformation applied to this particular function, so it becomes a highly expressive. But in this particular case, of course, I don't want to just transform to an object. I want to transform to an integer, and then I'm going to call a sum method on this. So as a result, you can see in this particular case, I got exactly the same result for both, but the second one is a lot more declarative. So what is the biggest difference between the two of these? The top code is called an imperative style of coding. That's what we've been doing in Java for a very long time, is imperative coding. The bottom one is called declarative style, and functional style is declarative in nature. Now there are two smells associated with imperative style, and we can quickly identify them. The very first smell is, in imperative you say what to do but also how to do it. Notice, just read loud and you will notice this. Create an integer and initialize it to 0 first. Then start taking one element from the list and then double that element. Then go back to that integer and add to it. And then, of course, make sure the loop manages properly. So you have to say every single thing. This is like talking to a toddler, right? You say, sweetie, hold the glass with both hands, look where you are going. No, don't run right now. So you got to tell every single detail. The bottom one feels like you're talking to an adult. Well, actually, knowing some adults I know, let me rephrase it. Talking to a responsible adult, right? So the point is, you simply say, can I have a glass of water, please? And the next thing you know, you got a glass of water. So you're saying what you want and let the library figure out the details about it. The second difference, please, yes?
If map will produce the same result, why would you want to use some?
The map is producing, if you get 20 input, you get 20 output. Now you're totaling all the 20 output in a single value. So map is a transformation of every single element in the collection. 20 input, 20 output. So you have 20 values, we want to sum them to one value.
No, but earlier you started with map.
That's right.
You came into map the.
Oh, so I want sum is, okay, good question. Sum is available on integer, double, long, and stuff like that. You cannot sum people, you cannot sum, books. So you're saying downstream, I'm applying an operation which is specific to a type, so you're kind of performing a type casting, right? So if you only say a map, you remain an object. It doesn't make sense to total objects, but in total integers. Absolutely. Thanks for asking that. So the idea really is that, and second difference here is, notice that in the case of the code here in the imperative style, another big difference is mutability. If you notice on line number 12 and line number 8, what did we do? We initialize total to 0, and then repeatedly we are modifying the value total. If you turn up the volume of the computer and run this code, total will actually say ouch, ouch, ouch on this line. So you are continuously mutating this variable. This code is very humane. No variable was tortured in the making of the result, as you can see. So the point really is that it's actually very explicit, but you're also avoiding mutability. Now, these things may appear really small in the beginning, but here's a very simple question to ask. If you go to the top code and say, hey, that's the loop, it's totaling the values, but I got a very large collection, could you please make the top loop concurrent? You probably are trying to look for the nearest exit, right? Because that's not a code you can make it concurrent so easily. Why? Because you have shared mutability on your hand. The code in the bottom doesn't have any explicit mutability in our code. As a result, it's very easy to make it concurrent, and we'll see examples of that a little later. So we can see the benefits of this style already in writing this code. However, this leads to one other big benefit, which is the ability to actually do function composition. Go ahead, please.
You're talking about mutability, right? How about strings if you want to append the strings there?
Yes. So the question is, how do you append a string? So there are ways to actually append a string. Let me give you an example of this. Since you asked, that's a really good question. Let's look at an example of this. That's the beauty of having these good questions. We can kind of take it in a direction we want to take it. Let's say for a minute I have a bunch of strings on my hand. So I have a string, and let's go ahead and say names equals arrays dot as list. And let's say I have a Joe here and a Jane here. And let's just say one more, let's say Jack. So I want to be able to, let's say, put them all into one string, a comma separator, right? So what would we normally do? We would say for int I equal to 0, I less than names dot size, and then we would say in this case something like I plus plus, and then we would do what? We would say output, and we would say the names dot get, and then get the value out of it. Well, that's great, but they're not on one line. Well, that's easy to fix it, right? So we can bring them on one line. So right there, they're all on one line. Oh, wait a minute, but they're not comma separated. Okay, no problem, we can do that. So we can put a comma in there, but there's now a stupid comma in the very end. How do you get rid of that stupid comma? Anybody was running into this problem? But more important, how did you feel? Right? Terrible, isn't it? And you are in denial that this cannot be true. Right? How could this be a modern development when you have to deal with that problem? And then after sincere thought and several hours wasted, you found there is actually one way to solve this problem very nicely. And that is, you simply have to say if I is not equal to, right? Why, right? So this is called torture the programmer, right? So there's no reason to do that. So let's give it a try here. So I'm going to output in this case, I'm going to say names dot, and I'm going to go back to the stream. But in this case, I'm going to say collect, joining by a comma, if you will. And you're simply saying, I want these elements to be joined. And for this, of course, you're going to bring in a static import on the class called stream.collectors. And once you bring in the collectors and bring in a static joining, so what does joining really do? Joining simply says, I'm going to produce an output by joining those values, but all of them comma separated. This is a lot more civilized way of doing it, as you can see. So in a functional style, there are pretty much higher order functions available to do a lot of these kind of operations, so you don't get down. The other code is called primitive abstraction, right? We are doing everything at the low level and enjoying the consequence of that. Whereas here we can program at a higher level of abstraction, good question, and then we can be done with it. So that's an example of how we can really write some code like this and work through it very nicely. Well, that's great so far, but how about one other thing? Well, one of the biggest differences in functional programming is we don't mutate objects, instead we transform objects. So we go through an object transformation where you go through a transformation of an object to another, to another, to another. And of course, it can be done efficiently depending on the implementation. Java does a wonderful job with that. So let's look at an example of such transformation. So to understand this transformation, I'm going to take a little problem here. So let's say the collection of numbers I have is 1, 2, 3. Notice 5, 4, not 4, 5. So 5, 4, 6, 7, 8, 9, and 10. So what I want to do is find the double of the first even number, let's say greater than, let's say 3. So I want to find the double of the first even number greater than 3. How would I do this? Well, let's do this in the imperative style we are used to. So I'm going to say result equal to 0, output result. And what should I do now? I'm going to say in here for int an element in numbers. And then of course I would say if number is greater than 3 and number mod 2 is equal to 0, then of course I would say result equals, I would say e times 2. Is that good? You want a break? There's only 40 more minutes in the talk. Oh, break in the code, of course. Break in the code, okay. So we got a break here. And so let's run the code. It produced 8. Is that good? Notice you went from it's broken to I'm still thinking. Well, here's what's going to happen, right? You write code like this. About 3 months later, you hear the knock on the door. You know who walks in? Person called tester. And the tester declares, your code sucks. And what do you normally say? I know it already, but tell me how it sucks. That's what I don't know, right? So that's the part we don't know. How is it sucking today? So the point really here is this code sucks and we don't even know how it sucks. But rather than saying it sucks, let's figure out why it sucks by writing this in a declarative style. So I'm going to output right here, and I'm going to say in this case numbers.stream, but I'm going to use a different method here called a filter. And I'm going to say if given an element e greater than 3, and I'm going to use another filter given an element mod 2 is equal to 0, and then I'm going to perform a map operation, one we did before, and then I'm going to say e times 2, and I'm going to say find the first, and ask for the very first value from this collection. So we implemented pretty much the same code, but we get a very different result. And when you see the result, it immediately tells you how the other code actually sucks. So if you look at the output in this code, notice the result was not an 8, the result was an optional 8. Now you know why the tester was complaining, right? The tester tried this with an input where there is no number which is even at all. Tested with an empty collection. And what did the code return for each one of those values? It returned a 0. Is 0 a correct result when you have no input at all? The answer is no, it's not. But of course, the traditional Java programmers would immediately say, well, I can fix it. And what would they do? They would change this to integer and then change it to null. How do you feel? Right? So this is adding more insult to injury, isn't it? So, but on the other hand, in the bottom code, you didn't have to go through all of that. It simply said it's optional, meaning it may or may not exist. Now the question is, how do you get the value out of this optional? I do have to warn you, this is one of the most threatening functions I've found in the JDK. It's called or else, and then you can ask for a value, and you can specify whatever you want to specify in here. So that gives you an idea about how you can perform this operation. So what did we just do? Notice that we used what's called a composition. And did you notice this beautiful lines of dots lining up vertically? That is a convention in Java 8. You place all the dots vertically, so it's very easy to read the transformation. And so you're saying, given numbers, get everything greater than 3, only the double values please, double them, and find the first one. So notice how the code begins to read like a problem statement. So you're not sitting there and scratching your head trying to figure out what the code is doing. Please.
There's no break in the...
There is no break. That's correct. It's a free fall. Right? So the beauty is that it really goes through and gets you the final result. And that's where the beauty is. It's nice transformation happening. Please.
So if I may,
sorry, yes, a person back.
In the case of the map, is sorting implicit, or if we
No,
change
not
the
at all.
order of the input, we break the
So here's a time I can plug my next talk to you. I'm going want to change the order, you got to say a sorted method on top of that. But that comes with the Stream API. There is one more question from you, please.
Yeah, there's no way that it has to apply all the elements.
So the map applies to only elements that's being filtered. So let's talk a little bit more about it. So we talked about what a map is. So one of the features of the map or the characteristics of the map is the number of output is equal to the number of input. But map doesn't guarantee the type of the output, right? Input could be names, output could be the addresses. Filter, on the other hand, says if you give me a set of values, I'm going to apply a filter. A perfect filter is where nothing goes through, right? So you get a null output, actually an empty list output. A complete hole lets everything pass through. But a typical filter is you get some values out but not other values. So in this case, you had 10 values coming in. Out of this, you only had 7 values go out because not everything is greater than 3. You only had 4 values come out of this. So the map only receives 4 values, and hypothetically speaking, right? So maximum of 4 values, we put it that way. And the find first picks the very first value and says I'm done, right? So they're all filtered through. You don't deal with 10 values in the map. In this particular example, the map deals with at most 4 values. Please.
So in this example, does do both filters actually go through the?
Very good question. You just led me to the next thing I want to talk about. So if you really think about it, so stay with me for a second. The point you are hinting on is what is the performance of this, right? That's where you're getting to. Are we really creating that many collections? And if we are, get out of here, right? So you're not interested in that anymore. Well, so the question is, what's going to be the performance of this? So to answer that question, I'm going to refactor this code just a little bit, and then we'll come back and answer that question. So I'm going to say Boolean here, and I'm going to say is even, int number, and let me just output here, let's say in this case, I'm going to simply return, and what am I going to return? Number mod 2 is equal to 0. And likewise, I'm going to create 2 more functions here, and the 2 functions are, I'm going to say this is going to be an int, and I'll call this as double it, and then of course I'm going to go ahead and double the value and return it in this case. And finally, here's the function called is greater than 3, and I'm going to simply return a greater than 3 in this case. Now that I refactored these, let's go back and do one more thing. Rather than calling this function, I'm going to say sample is greater than 3, and I'm going to go ahead and call, in this case, sample is even, and then finally I'm going to say sample, and I'll call it double it. So I just refactored just a little bit. But let's get to your question now. Now the question is, what's the complexity? Are we paying more price for this? Well, let's look at this first to understand, then we can compare it. So help me out here. How many operations are we going to perform? Remember, my list contains 1, 2, 3, 5, 4, 6, 7, 8, 9, and 10. So I come in first with 1. Is 1 greater than 3? No. It's a short circuit, doesn't go any further. Is 2 greater than 3? No. Is 3 greater than 3? No. Is 5 greater than 3? Yes. Is 5 even? No. Is 4 greater than 3? Yes. Is 4 even? Yes. Double 4 and break. So how many did we do so far? 8. 8 computations, right? So keep that in mind, 8 computations. Now imagine for a minute that this comes in and we filter out all the numbers greater than 3. Naively, let's say it is going to do that. How many operations would that be? If I'm going to compare every single value to see if it's greater than 3. 10. Dead on arrival, isn't it? Because 10 is greater than 8. But let's entertain the thought a little bit more. Now that we have 10 values computed, we got 7 as a result. Then we compare is even on 7 values, that's 17. Then we got 4 even numbers, that's 17 plus 4, 21. Now, if somebody says, you have a choice of paying $8, or look how beautiful this is, but you paid $23, would you take it? No, right? We probably won't. That's okay. We are among friends. All of us are cheap. So no, we won't take it. Right? Absolutely. So yeah, we're not going to pay that extra price. 4 times more. Heck no. 3 times more. Heck no. Well, I would say the same thing as well. But what if this is going to be exactly the same performance? But how could that be? Well, I forgot to mention one thing about streams. I noticed this property of streams only among my children. They both are lazy to the bone. So I go to my children and say, are you done with your homework? Yes, Daddy. How did it go? Wonderful. Any problems? No, not at all. Can I see it, please? Sure. And they disappear. And then an hour later, where are they? Well, probably are working on the homework, right? So these guys are exactly like that. So you go to a stream and say, stream, and the stream says, yeah. Well, stream, go ahead and filter. Done. Filter again. Done. Map, done. Find first. Oh dear, we got to do some work. So they only do work when they absolutely have to do the work. So that goes to your question. So here's a way to think about it. Do not look at this. This is where it's deceiving our eyes. Don't look at this as a list, entire list is taken, and that entire list is producing another list, and then another list, another list. That's not the way it works. Instead, look at it a little differently. Imagine for a minute you are standing right there. That's your feet. Imagine you're standing right there. And what you're going to do is you take this 1 and you drop it vertically. That's all you do, right? Just the number 1. And what does the number 1 do? The number 1 hits this over here and bails out on the right side, right? Because 1 is not greater than 3. You say, oops, that didn't go far enough. You try 2. That goes the same door. 3 does the same thing. Then you put 5. What happens to 5? 5 goes through that, goes to the second level, but it bounces off of the second level. Making sense? Now you take 4, and guess what 4 does? 4 goes through that, 4 goes through that, 4 goes through that, 4 comes to find first, and find first says, cool, I got what I want, and they fold the shop. They don't do any more work, so it will never process 6, 7, and so on. Just to see that it's actually true, let's do this over here. I'm going to output here, double it for, and let's say number, and I'm going to output here, let's say is greater than for number again, and then finally I'm going to say over here, is over here, let's go ahead and say is even for, and let's say number. And I'm going to add one more thing here. I'm going to come to this very end, and I'm going to also output, just for us, done. So when I run this code, notice the output. It did exactly what I said. And how many computations did it really do? Exactly 8. So this code is extremely concise, expressive, and you have absolutely not lost any performance. You only stand to gain performance. This is one of the beauties of Java. Java did not simply implement Lambda expressions and say good luck. And Java could not do a lot of stuff that other languages did. If you compile the anonymous inner classes in languages like Scala and Groovy, and take a look at the jar file, you will see a lot of inner classes. Not so in Java. Java uses some very efficient techniques. And of course, there's a reason for it. And the reason is, when your language is used widely, like there are 9 million programmers using your language, out of which 1 million people know where you live, you design language very differently. So they had to take the time to really design for efficiency. As you can see, that's already baked in. So, but it's even better than this. If you notice, all this work, but notice what I'm going to do here. I'm going to go and remove just the last line of code. I'm only removing the find first. That's all I did. Now what happened? Java has 2 kinds of operations on streams. Those that are called intermediate operations and those that are called terminal operations. The things like filter and map are called intermediate operations. Things like reduce, find first, sum, all of those are called terminal operations. Now I remove the terminal operation. What's going to happen? This should be very familiar to you. I know you. I'm sure you know some people at work like this, right? They come to work in the morning. They look around and say, "Hey, where's the boss? Oh, the boss is out sick today." And they say, "Yes, I don't have to do any work today," right? That's exactly what these guys do. Notice when I run this code, all you saw in the output was simply literally a done, right? If you really think about it, let me remove the print line also to make it really evident here. So notice in this case I have a find first, but I'm going to remove the find first in a second, so you can see all that output, but I just removed the find first and run the code, and notice all we see is a done, because that's a bunch of lazy people, right? So they said, "Oh, we don't have to do any work, because who cares?" So the point really is, it is absolutely lazy. Oh, pardon me, but we pronounce lazy very differently in Java. It rhymes a little differently. Whenever you hear the word lazy, you should hear it as efficient, because that's what it really is it's very efficient, as you can see right there. So that is already baked into the language, as you can see, very, very powerful. And of course, what are the benefits of this? Well, the benefits, yes please.
Since some of the intermediate operations, it could be differential, right? Some running in a parallel thread in the common.
Right.
Multi-threading in the common.
Absolutely. So the question is, what about, let's say, phenomenon? Let's sit back for a second. One of the things we should guarantee is that the functions, okay, since you asked, let me give you another example. And it's a good example to look at it because I see a lot of people do it, and hopefully we will know not to do this. So let me show you an example here real quick. Now, some people say, well, I'm going to do functional style, and let's say I want to total all these values. That's all I really want to do. So to total all these values, how would I total these values? So here is a wrong way to total it. You say total equal to 0, and then you say numbers dot for each, and then you get an element, and you say total plus equal to element e, right? So you try to write code like this. Now, what is wrong with this code? Well, the very first thing that's wrong with this code is Java doesn't like you, right? So it complains you cannot do this. But you know how programmers are, right? They say, really? You don't like it? And then I've seen programmers say, how about doing this? So you change this to a new int square bracket 1, and then of course you come back here and say 0, and at this time Java says, okay, I give up, right? So you can always beat around this. So you never challenge a Java programmer, right? Because if they're determined to write bad code, they will. So the point really is that you don't really want to do that. So what's wrong with this code? What's wrong with this code is, notice what this function is doing. This function is quietly sneaking around and making a change to a shared state. Changing a shared state is crime punishable under law, right? And you shouldn't change a shared state because if you do it, it becomes extremely hard to reason the code, a lot of other things to be written. So in functional style of programming, we write what are called pure functions. A pure function is a function that doesn't have any side effects. It is not affected by something outside, and it doesn't affect something outside. So a right way to write this code is actually not to go around and try to mess with that, but instead simply to say something along the lines of saying, for instance, you could simply say the value total, let's do that again, so total equals to, but this time around we're going to say numbers dot stream, and then you can simply perform a reduce operation where you say integer sum, and I want to perform that operation, and when you're done with it, you can simply display the total, and this is a more civilized way of writing the total. And the beauty of this is a sum is a pure function because it simply receives an input and gives you an output, doesn't change any global state. So to go back to your question, when you write code in functional style, you need to make sure that you don't mess with any global state. Well, one of the benefits of not messing with the global state is automatically things become parallelizable. We don't have to sit there and worry about what's going to happen if we parallelize it. So you almost get it for free, if you will, right? So that's one of the biggest benefits you get out of this. So given this, let's talk about one other thing we can actually do to put this to a better use. So let's talk about this. We got code clarity, as you can see in this case. And I would say code clarity because you're able to write the code and you're able to reason the code very easily. Now, when we say the code is concise, we got to be careful about the word concise. I've actually seen code examples where your functional style code is about 3 or 5 lines more than the imperative code. And you cannot look at this and say, see, this is a little bit bigger, so it's not concise. There's a difference between the word concise and the word terse. Concise is short. Terse is short and waiting to hurt you, right? So you don't want the shortest piece of code, you want a concise code. That's very important, and it gives you that. So you got code clarity, the code begins to read like the problem statement, so you're able to relate back to that very nicely. And the other benefit you get out of this is you have fewer errors. Now, why do we have fewer errors? First of all, because the code is expressive, you got fewer errors. It becomes very transparent. But the other reason why this is better is that you also have the ability to write the code, and without mutability, you have fewer errors on your hand. That's another benefit, absolutely. But this automatically leads to a very easy parallelization. Now, how could we really parallelize this? So to understand this, I'm going to take another example and work through it. So let's say for a minute, I've got a bunch of ticker symbols on my hand. So tickers.symbols gives me a bunch of ticker symbols I have on my hand. And I'm going to make sure that I'm connected to the web. So let's make sure I'm able to log in. Yep, that's good. So here's what I want to do. I want to go and find some stock prices. But here's what I would like to do. Find the stock price that is highest but less than $500. So I want to say find me the highest stock price but the one that's less than $500 in price. So how would we go about doing this? Let's do this imperative first, then we will do it declarative and see where it takes us. So here's what I want to do. I want to start out first of all and say, well, let's go ahead and time this code. So I'm going to say time it dot code, and I'm going to give it a little piece of code that is not really doing anything at all, and I'm going to simply measure the time this code is taking. Well, I'm not doing a whole lot, so the time is 1.e-4, so that tells us that that code didn't take a whole lot of time. But I'm going to replace this with find imperative, and this is going to take tickers.symbols as a parameter. So let's go ahead and write this code, first of all, in the imperative code style. So I'm going to say find imperative, and what am I going to send to it? A list of string, we'll call it symbols over here. And once I get the symbols on my hand, next thing I want to do is to do the work. So I got a list of symbols, but I want the stock prices for it. So I'll start out first of all saying stock info stocks equals new array list, which is empty. You can feel the smell of imperative style already, right? What in the world is a stock info? Well, the stock info is just a POJO. It contains a ticker and a price, a constructor to set the values, and a toString simply to print it out. So not a whole lot of exciting thing happening in the stock info, it's just a POJO. And it's got a ticker and a price, that's it. Now what do I do? For, and I'm going to say string a symbol, and that comes from symbols. And what do I do with each of the symbol? I'm going to say stocks.add. And in this case, I'm going to add it to this particular stock. What do I do? I'm going to say stock util. And in this case, stock util.getPrice, and I'll get the price for the given symbol that we have. Let's take a look at stock util and see what it contains. The getPrice method, as you can see here, simply goes to Yahoo Finance, gets the current stock price, parses it, and then puts it back into a stock info object with the ticker name and the price that you got, right? So not a whole lot happening, and that's what it's getting to us. Well, at the end of line number 9, what I have on my hand is a collection of stock info. In other words, I have all the prices I want. But I'm going to do one more thing. I'm going to say stock info. This time I'm going to say stocks less than 500 equals new array list one more time. So I create another empty collection. Then I say stock info, and I'll call this as stock. And this comes from stocks. And what am I going to do this time? I'm going to say if the stock util, so I'll call on the stock util, dot is price less than 500. So let's quickly take a look at that one. Is price less than is returning a predicate. And in this case, what it's returning is actually it's returning a function itself. A predicate is also a single abstract method interface. In Java, we call this as functional interfaces. So instead of returning a value, we can return a function. In a way to think about it, if somebody comes to you and says, can I have a cup of coffee, please? Rather than give them a cup of coffee, you give them a coffee maker so they can make coffee with it. So the point is you're returning a function rather than returning a value. That's what you're doing here. So in this case, what you're going to do is use that particular stock info, predicated return. So call a test on it and say stock. And if it is true, and I'm going to say stocks less than 500.add and add the stock to it. At the end of line 15, now you have stocks which are less than $500 in price. But what you want is the highest of those values, isn't it? So to get the highest of those values, what I'm going to do here is to define, let's go ahead and say in this case stock info, we'll call it dummy equals new stock info, a no name and a 0.0 initial value. So I say stock info, high priced, let's call it as equals dummy, and I go through another loop, stock info, and I'll say for each of the stock, but this time it comes from stocks less than 500, and I'm going to say high priced equals stock util, and in this case dot, I'll call pick high of the stock and the high priced in this case. So if you look at what pick high is doing, it compares the price of two given stock info objects and returns whichever has the highest price. So the last step over here would be to output, in this case, the high priced. So let's go ahead and run this code, and while it's running, let's talk about what it is going to provide for us. So in this case, let's see, let's fix this. This is high priced equals. I make this static so it can be accessed here. There we go. So let's go ahead and run this. Now what did I do in this code? And when the result comes back, we'll continue. It usually takes anywhere from 30 seconds to 3 days. So the point really in this case is, we first took the symbols and we got all the stock prices. Then we took all the stock prices and got only the prices less than 500. Then we took the prices less than 500 and cherry picked the one that is the highest price by comparing it, right? So that is all pretty much we did. Now, of course, you may look at this code and say, wait a minute, you know in the right way would write 3 loops for this, you would be writing 1 loop, isn't it? Now, what will that 1 loop do? That 1 loop will do everything. It will do comparison, it will do checking, it will do addition, it will do update. But of course, there's one problem. If you make that code so short and do everything in there, that code becomes a bit hard to read, but that's never a problem for us. We only write code, who cares about reading the code? So the point is, we could write and merge them all together and write, right? So anyways, hey, look at that. We got Amazon at $369.51, if somebody can remember that price, $369.51, and it took about 26 seconds to do this work. Let's try this example in declarative style and see how this is going to look like. So how would I write this in declarative style? And I'm going to ask for your help to do that. So notice what I'm going to do. I'm going to say timeit.code, and this time I'm going to say, let's call it as find functional. And I'm going to say pickers.symbols.stream, and I'm going to pass a stream to this function. So right there we have the function in front of us. It's called a stream. Let's go ahead and bring in a stream into the picture. So let's say stream.stream. So there we go, we bought a stream. And now that we have a stream on our hand, let's go ahead and use it. So notice what I'm going to do now. I'm going to say, in this case, public static, let's say void, and we'll say find functional. I got a stream of string called symbols. Now I'm interested in timing it, so I put into the time already, so we are good. So what should I do? Output. So what's the very first thing I'm going to do? Symbols dot, we already have a stream. So help me out here. We got a collection of symbols on our hand, but I want a collection of prices from it. What function would I use for that? Map, I heard. Great, you've been attentive. Great. So I use a map, and I'm going to say stock util, and get price I'm going to call. So here comes the next question for you. I got all the stock prices now, but I want to only get prices less than 500. What method would I use for it? Awesome, filter. So we're going to say filter here, and the filter takes a predicate, and I have a stock util on the other hand, and is price less than 500 already returns a predicate, so that's like a marriage made in heaven. And I have a last question for you, but I'm going to give you a quiz for that. Well, salt is to pepper as map is to reduce. Isn't that a great game to play? So yes, reduce. So we are really doing a map reduce algorithm here. That's what we're doing, right? So reduce, and what am I going to say? Start with dummy and stock util pick high. That is basically what I want to reduce over here. So we have written the code already. Let's go ahead and run this code. While it's running, let's talk about it. So I'm running the code, but here's the question. If you were given a choice, would you write this code or would you write that code in the top? The one in the top, of course, if you're a consultant getting paid by the number of lines of code you write, right? But the bottom one, if you really want to write a clean code. But look at the beauty. The code begins to read like a problem statement. Given a list of symbols, get me their prices, select ones less than 500, and pick high. It doesn't have anything to think about, right? So it's very direct, very easy to understand, and it's very transparent and expressive. And look at the value you got. Is the stock price the same? Well, sad news. Just because you write functional code, you don't get better stock prices. Is it kind of about the same? Yes or no? Yes. If you said no, what's your problem? Well, yes, it's about 26 to 28 seconds, no difference, right? If you want real gains, look for real gains, right? That's a network speed. So you're okay with that? You better be, okay? All right. So, given this, I want to say one thing about this code, right? Notice the code in the top and the code in the bottom. There is one big difference in the code. And that is, one of the philosophies I would like to maintain is, I want the code to read like a story, not like a puzzle. So, in other words, the code in the top is like a puzzle, right? Domain experts comes to you and sits down and says, what does this code do? Well, it gets the price, it gets less than 500. What do you think? Is that good? And you're having a conversation. The top code, the domain expert says, what does that code do? And you look at the domain expert and say, that's what I'm trying to find out, be quiet, right? So that is like a puzzle. You don't have a clue what the code is doing, right? So that's basically the question. Well, that's great. We are looking at this code, but is there a benefit to writing code like this? We already saw several benefits to writing the code like this. Absolutely, this is expressive, easy to understand, easy to read, but is there more benefit? Let's ignore this for a second, we'll come back to it. Imagine you only have the top code, and you have the top code, and maybe you refactor it into one loop. Now you got that one loop, and now what happens? A few months goes by, and you know how projects go, right? Eventually they come to you and they tell you, well, this is great, but we have a problem here. We have this program being extremely slow. And we tried this with 100 stock symbols, and it's taking forever to run. So everybody in this team is staring their hair apart, and they're trying to figure out how to make this code faster. And then somebody comes with a clever idea and tells you, I got a great idea. And you say, well, what's the idea? Well, we got multi-core, right? We could use multi-threading. And immediately your mind races to the previous job you had. Remember the previous job you had? The previous job where you went to work and everybody smiled at each other. And then one day, they introduced multi-threading into the project. And then what happened? The code started changing rapidly. And then very soon after a few weeks, what happened to the code? The code that was beautiful and you enjoyed looking at every day turned into a monster in front of you, right? And this multi-threading and locks and synchronization, you're like, oh boy. And one thing you did every day for sure, you went to work every day and started debugging that monster. And after a few months you realized this is never going to end. And then you came to this conclusion. While debugging, you applied for the other job. That's called concurrency, right? And you're like, no, I don't want that concurrency, right? While debugging, you applied for the other job. So the minute somebody says multi-threading, you start writing the resume, right? You're like, oh, I don't want to do that. Well, what if the code structure is exactly the same? What if you don't have to make any change at all and you can get concurrency? This doesn't come for free. It comes from one thing that is very hard to find, which is called discipline. But we got it, right? So what did we do? We made sure each of these functions are pure, and we didn't really sit there and mess with the state or global state. So when I ran this, how much time did it take? 28 seconds, and the only change I'm going to make is a parallel stream. So I just changed the word stream to parallel stream. That's all I did. I didn't make any other change to this code. I simply said, rather than running as a stream, run as a parallel stream, right? And the rest of the code works. And the person who said, no, I want to talk to you now. Just kidding. So the point really is that you really want performance gain. You don't gain performance by little fiddling with the code. You want to go for the bigger gain. And we are afraid to go for a bigger gain oftentimes because that's a very treacherous path for us. The minute we start changing the code, it turns into a monster, and then it becomes extremely hard. But the beauty of this is, remember I started the session by saying these methods are polymorphic. Well, look at the beauty. On line number 36, and line 36, line 37, line 38, notice we said map, filter, reduce. We never told it how to do the mapping, how to do the filtering. And the beauty of not telling how to do is it's very easy to change what you never did. And the beauty of this is you said, when I bring in a stream, you perform a sequential map, a sequential filter, a sequential reduce. But now you're not sending a sequential stream, you're sending a parallel stream. We all know what that means. says, look what I have, I got a parallel stream, and launches threads from a thread pool and sends all those things on a thread pool. And once the maps are done, you don't have to wait for one stock price to be found for another to be found, so they go concurrently. And guess what? Filter is exactly the same as well. To know whether a stock price should be kept or rejected has nothing to do with other stock prices. So the map and the filter happen absolutely concurrently. The reduce, on the other hand, applies a tree structure because of associative operation. As soon as prices get arrive, it can start computing in this particular case to find the high one, so it can determine that fairly effectively. And reduce can be as parallel as it can be, and if it cannot be parallel, only that part can be done sequentially. But if you really think about it, the part, go ahead please.
So, this parallelism happening across map, filter, and reduce, or within map, it can be parallel.
So each one. So think of this as, draw the picture in your mind. Map is happening in parallel, and then filter is happening in parallel from there. So think of like a relay, right? Like a relay, you run and hand out the relay, and the other person takes over and runs. So you got multiple tracks running. They can be running at their own pace, and then they can continue.
So parallelism is at each operation level.
That's right.
All that is completely covered.
Not at all. So this can run in parallel and then pass it on to the next one. So you could potentially come up to this point in parallel. And the reason for that is these are fused together as one operation. Remember laziness. So these guys are already fused together. The stream is lazy, so it's optimized already, so it can run them in parallel together. So the map and the filter would combine together and run in parallel as one operation, but individually for each element. So please.
Can you define the number of threads or?
Good question. So what about the number of threads? So there are three answers to that question. The first answer is the number of threads given to you is determined by the number of cores you have. That's a default behavior. So if you have 8 cores, you get 8 threads, right? So that's the first answer. The second answer is there is a flag at the JVM level, minus D, blah, 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 and then you can specify the flag and say, give me 100 threads. Then it gives you as many threads as you ask, and every operation you do on a parallel stream will be on the pool of that many threads. That's the second answer. The third answer is, you say, no, I don't want to control it on the JVM level, I don't want to be controlled by the number of cores I have. Then what you do is, take that line number 31, and put that into a for-join pool. So you know when execute a service already, right? So you create an execute service, new fixed thread pool, and then you call submit on it. Rather than calling an execute a service, create a for-join pool thread, and then do a submit and put that code in there. So you look around and say, I'm not the main thread, I'm the thread pool thread, and I'll use that thread pool. So your for-join pool will become the number of threads for you. So you can control it at the function level as well, depending on where you're running. Excellent question. Yeah.
Can I ask a follow-up?
Please do.
So port join operations have its own thread pool.
Yes.
So you are saying that I can go as far as saying that use port join pool stop using
Your own for-join pool.
my own pool.
Yes.
Okay, it's not like
No, no. So they use one automatically. If you don't say anything, they use theirs. But you can submit in your own for-join pool, then it becomes that. And then that uses the number of pools that you have. Please.
So how do we handle failures? How do we handle failure?
How do you handle failures? Well, failures are a bit of a problem no matter where we go. And so in this case, if one of the lambdas throw an exception, you need to handle that within the lambda, like within the map call itself, and then you need to find a nice way to propagate that up. So my recommendation is come up with a hygienic data where a data can have both an error and a valid result, and then you propagate that up the chain and deal with it. But absolutely, you have to handle it. If you throw checked exceptions, you will have problems because these interfaces don't accept thread exceptions. If you throw a runtime exception, that only leads to other problems. So you have to handle exceptions at the function level and then take them as a hygienic data and error and transport it. Absolutely, you have to do that. Please. A little louder, please.
Here, the terminal function you are using reduce. If we use maximum,
Yeah.
right,
So
will because in that situation you will not be depending on your implementation of peak height, right? Will it make it faster?
it will make it faster up to the point where it can. That's one answer. The second answer is you got to be very careful when it comes to parallelism, because parallelism expects that the order doesn't matter. So if the algorithm depends on an order, you don't want to parallelize it just without thinking about it. And then that's one of the questions people normally ask is, if all I have to do is parallel stream, why don't I do this all the time? And the reason is, you know the data size, you know the task duration. If it is too small or too short, you will be wasting time starting threads, and your parallel code will be running slower than sequential code. Whereas if it really deserves it, you can use it. So that's why I call this the master switch. You kind of sit there and say, this problem deserves it, I'll flip the switch and I can get the performance. This problem doesn't deserve it, and you can do it even at runtime, and then you can switch switch back if you want to. I think somebody else had a question, please.
Yes, a different question is, what editor are you using?
I'm using an editor called TextMate. Please.
So, how much garbage collection and memory allocation?
Right. So garbage collection and memory allocation. First of all, the beauty of this is garbage collection would happen just the way garbage collection happens in Java, no difference. But the real concern there, which you're implying is, are we creating more garbage to be collected? Well, that's the good news. Is because they're using invoke dynamic code, they're not really creating as many anonymous interclass objects as we would otherwise do. So they're pretty kind on memory usage as well. You will certainly have more objects to work with, there's no doubt about it, but not as many objects as you would if this was done very naively. So there are a fairly decent amount of optimization to keep that in mind.
But in this scenario, you have made a lot of threads, right? That's comparison. So all those are threads flags are still available.
No, the threads are from tools. Just like HTTP service. I mean, we know that we should never be creating threads arbitrarily, so they now will definitely do that. It's on the thread pool. And the thread pool is available whether you use it or not. And then you just latch onto it. Of course, if you create your own thread pool, you need to manage it. But that's much like the services we normally use, right? So we don't have that available to us absolutely. So we saw the effort it took, or the lack thereof, to really convert this and go into using this particular solution. So very, very powerful, as you can see. So one of the things, like I mentioned, is I want to quickly show that to you because there was a few questions related to it. Is the benefit you get out of the things they did. So if you really think about it in terms of what they have done, let's look at one other example here real quick to understand what that means. So I'm going to go to creating a little Lambda here, but we talked about how functional interfaces relate to this. So let's say we have a list of integer, and in this case I'm going to say numbers equals, let's say arrays dot as list, and let's say just 3 values to work with. So I'm going to say numbers dot for each, and in this case I'm going to bring in the consumer like we did a few minutes ago. So I'm going to say function dot consumer, and let's say in this case I'm going to simply say new consumer, and then I'm going to say integer, and let's say in this case public void accept, and this is going to take a number, let's say, and all that I do is output the number. So this is essentially just taking in a collection and working with it. So that's a consumer that we are dealing with in this case. Let me see what it's not an abstract class. This is going to be what was that? Oh, integers. Yep, thank you. So, so this is basically, there we go. So if you look at this, well, if this is so beautiful, notice what you could also do. You could say numbers dot for each, and in this case you could simply say, given a value, output the value, right? Now, here's the deal. This gives us an impression that anywhere we use an anonymous inner class, we could use a Lambda. But that's not entirely true. Anywhere you can use a single abstract method interface, you can use a Lambda expression. Those are called functional interfaces. Now, given this, if this is so beautiful, so concise, would you write this once? You probably would write it several times, isn't it? Well, leave the thought aside for a minute. If they take this and, let's say, convert it to this, what is going to happen? If that's all they do, what will happen? To understand that, let's take a quick look under the hood. So I'm going to go back here to the terminal, and let's go to where I have the code here. So I got all the stuff here in this directory. So I'm going to go back and look at what I have on the disk. So if I say classes and I say sample, notice in this case, I immediately get a sample and sample $1. Now clearly, if this is so concise, you're not going to use it once, you're going to use several Lambda expressions. And if every Lambda expression converts to this, what's going to happen? Very quickly, you will see that. And it's not going to make anybody happy, right? Your jar files are going to become bloated. Your garbage collection is going to be taxed. You are going to have concurrency issues, slow load time. Every problem you can think of is going to become a problem. So what do? Well, here it comes. Leave the thought aside. We'll come back to it. Then they did something which was pretty remarkable. They were working on Java 7, and in Java 7 they implemented a feature that they really did not have to implement at all, but they still implemented it. I call this a simple act of kindness. There's no other way to name this. They looked around and they said, look at our brothers and sisters who are programming in dynamically like languages like Ruby and JRuby. Why don't we help them? I mean, they could have done what they have done very effectively for years, pretend that no other language exists. But instead they said, let's just help them out. And so they built this feature called invoke dynamic. The word invoke dynamic has two names in it, invoke and dynamic. Invoke simply, the best way to explain invoke dynamic is look the other way. So essentially, I'm going to thank you. So essentially the idea is that you don't want to really, so the idea really is that you, the basic idea behind invoke dynamic is that you essentially want to really bind to some other location very dynamically. It's polymorphism at the runtime, if you really think about it at the bytecode level. So the idea really is, you are saying, I'm going to attach this function now, but I'm going to detach this and attach to another function dynamically. I can be very dynamic at the very underlying level. But the best way to explain this is to just say, look the other way. So the point is, you have static typing, but you all will completely agree with me, it's a lot more fun to get error at runtime than compile time. So invoke dynamic really says, I'll bind at the runtime rather than at the compile time. And so this was purely a feature implemented to help these dynamic type languages. However, the basic essence behind this is, when they started working on Java 8, they started looking, how do we really implement this? And somebody came up with the idea, which probably was received by, are you crazy? Because they said, why not use invoke dynamic? And the beauty of this is that suddenly, all of a sudden, the language that makes the best use of invoke dynamic is Java and not these other languages. So they completely re-implemented invoke dynamic in Java 8 to make this happen. So in a sense, what's going to happen here is, when you go back and implement this in here, notice with all these anonymous inner classes in place, you will notice that when I run this code, you will notice that if you come back and they ask for this, there's absolute silence here. So they have no single anonymous inner class, if you will. But if you look at Java P-C, which is an alias on my machine, and take a look at the classes, you will notice that it pretty much uses invoke dynamic. So I associate this as an act of good karma. It pays up really well, as you can see. So that's where the performance comes in as well, in very nicely doing this. So to summarize what we talked about, we have looked at the most essential feature here, which is Lambda expressions. But Lambda expressions don't work alone. They work in conjunction with a lot of other features, like streams, for example, right? So streams do a lot of magic up in the scene. But Lambdas give us a way and open up this beautiful door to do functional programming. Now we got to be a bit careful about this, of course. We got to make sure we don't really mess with the shared state and all that. But if we can maintain the discipline, I think there's a lot more fun. I'll end with one small statement. We saw some changes in Java 8. Sure, there are syntax changes, but I'm going to say the biggest change in Java 8 is in the minds of the programmers. I hope you benefit from that. Thank you.